Okay, so this is my lesson on colligative properties. So I start off by defining a colligative property. I say that a colligative property is most simply explained as a substance that is added to a liquid to alter its liquidious state in some way. So that means that it's used for safety in public, medical, and technology. Now, I know that I did read that straight off of the thing. However, I did that because I wrote this part fully on my own, and it is the definition that helped me understand what I was learning about the most, and I feel like it summarizes it the best. So, I'm going to go into how it is used. So, that public, medical, and technology that we just talked about. So, in public, I say New York, Pennsylvania, really any place that freezes. And yeah, I use New York and Pennsylvania specifically as a reference for people in America who don't live in a place that will freeze and don't have this. So it just kind of makes this more of a real life scenario that they can kind of picture. But what will happen is people will put salt on the ground so that way the ice takes longer to form, which allows for people to then walk on the water or the surface, whatever it is, and then that will kind of inhibit the water from freezing for a longer duration of time than if it was just plain water sitting on the ground. Then it's used in medical, so it's used in IVs when, because the point of an IV is to drop liquids into your body and your cells to take them in. So this is actually like very, very dangerous because your cells can only hold so much liquid inside of them, and they have a semi-permeable membrane, which means that this liquid is going to find its way inside. So the point of the colligative properties is to make it so that only some of the water can get through, or some of the liquid can get through, which then allows for regulation between the semi-permeable membrane so that way your cell doesn't blow up and then thus you die. Then a car motor is the most common technological example I've found through my research. It's a little confusing, so bear with me here, but essentially you have to first understand that ethanol glycol and water are used to create antifreeze, which stops your engine from freezing or overheating. So the ethanol glycol will separate equally onto each part of the water molecules, and thus it will prolong the hydrogen bonds being formed between the water molecules, giving it more time before your engine is going to freeze or overheat, which will then give you more time to leave wherever you are that's causing that to happen. Okay, now my research. So, colligative properties are physical changes. It is very important to know they are physical, nothing else. And what that means is that the bonds themselves, the hydrogen bonds in the water, are physically being blocked by salt particles. So that way they can't form for a certain amount of time. Eventually, the salt will move out of the way. Bonds are always going to end up winning, but it will prolong the effect, allowing for more time to occur and then slowing that freezing process down. So it's very important to note they are physical. There's two terms that are very important. I don't use them a lot in my speaking about colligative properties, but scientifically, you would use them a lot. So one is solvent and the other is solute. So a solvent is the substance that is doing the dissolving, and then the solute is the substance in which is being dissolved. So this is primarily used in the osmosis part, but I want to get those defined now. So let's talk about vapor pressure. So vapor pressure is when you boil water or any liquid for that matter, but I'm just going to use water because I think it's the easiest liquid. We all know it. So when you boil water, we can all see steam coming off of it. It's vaporizing, turning into a gas, whatever you picture when you hear boiling water. However, the colligative properties act as a physical barrier that will stop some of that vapor from getting up into the air and escaping, which could help in different scenarios. For example, the engine, if you don't want it to overheat, you want to slow it down. How are you going to do that? By containing the vapor inside of the water, so that way it's not releasing into the air and causing the air to get really hot. Okay, then we get boiling points. So boiling point elevation, so this is pretty much what I just talked about, but not really. So what happens when something boils is all the bonds, all the IMFs have to break in order for it to turn to a gaseous state. So let's take water. All the hydrogen bonds, every single one of them has to break in order for it to boil. And that takes a long time for water, but not for something like ethanol. So when you don't want it to boil, you would put stuff in there to make it so that way it's not going to boil. And so you would do this by lowering the vapor pressure, which is what we just talked about. The colligative properties will contain the vapor inside the water. So now let's move on to freezing point depression. So freezing point depression, this is what I was talking about earlier with the water on the side of the roads with the salt. It stops those bonds from being formed. So this is the opposite of boiling. Boiling, you want them to break. Freezing, you want the IMFs to form. And if you want to prolong freezing, you're going to physically stop the IMFs from forming for a prolonged amount of time. And then this makes it so that more energy is needed, or it would need to be colder out in order for the water to fully freeze. And then osmotic pressure. Osmotic pressure is confusing, but it's essentially there's a liquid over here and a liquid over here and a semi-permeable membrane. And whatever is inside the semi-permeable membrane has X amount of liquid it can hold, and it needs to take this liquid too, so it gets out X amount, so that way it's still holding the correct amount that it can hold, and it has now taken in what was over here and gotten rid of some of what was originally inside of it.